How the human eye works. Complete eye anatomy explained. Have you ever wondered how your eyes can instantly recognize a familiar face, read a book, enjoy a beautiful sunset, or admire the colors of a rainbow? The human eye is one of the most advanced and fascinating organs in the body. It works continuously from the moment you wake up until you fall asleep, collecting light, processing visual information, and sending millions of signals to your brain every single second. In this video we are going to explore the complete anatomy of the human eye and understand how vision works from the moment light enters your eye until your brain creates the images you see. By the end of this video you will have a clear understanding of why the human eye is often called a masterpiece of biological engineering. The journey of vision begins with light. Everything you see depends on light reflecting from objects around you. When light reaches your face, it first enters the transparent front surface of the eye called the cornea. The cornea acts like the first lens of a camera, bending incoming light toward the center of the eye. Because of its curved shape, the cornea performs most of the focusing needed for clear vision. After passing through the cornea, light travels through a clear fluid called the aqueous humor. This fluid nourishes the front part of the eye while helping maintain proper pressure inside the eyeball. The light then reaches the pupil, which is the dark circular opening in the center of the eye. Many people think the pupil is black, but it is actually an opening through which light enters the eye. The size of the pupil changes constantly depending on the amount of light around you. Surrounding the pupil is the iris, which is the colored part of your eye. The iris contains tiny muscles that automatically adjust the size of the pupil. In bright sunlight, the pupil becomes smaller to reduce the amount of light entering the eye. In dim conditions, it becomes larger, allowing more light to enter so you can see better. This adjustment happens within seconds without you even noticing. After passing through the pupil, light reaches the crystalline lens. Unlike the cornea, the lens is flexible. It changes its shape to focus on objects located at different distances. When you look at something close, the lens becomes thicker. When you look at something far away, the lens becomes thinner. This remarkable process is known as accommodation and allows your vision to remain clear whether you are reading a book or looking at distant mountains. Behind the lens lies a large transparent gel called the vitreous humor. This jelly-like substance fills most of the inside of the eye, maintaining its round shape while allowing light to pass freely toward the retina. The retina is one of the most important structures in the human eye. It is a thin layer of nerve tissue lining the back of the eye. The retina functions much like the image sensor inside a digital camera, capturing incoming light and converting it into electrical signals. Inside the retina are two specialized types of photoreceptor cells called rods and cones. Rods are highly sensitive to light, allowing you to see in dark or dim environments. They are excellent at detecting movement but cannot distinguish colors. Cones, on the other hand, function best in bright light. They are responsible for sharp, detailed vision and color perception. There are three different types of cones, each sensitive to red, green, or blue light. The combination of signals from these three types allows humans to perceive millions of different colors. Near the center of the retina is a small area called the macula. This region provides the sharpest and most detailed central vision. Within the macula is an even smaller area called the fovea, where cone cells are packed together more densely than anywhere else in the eye. Whenever you read text, recognize faces, or examine fine details, you are using your fovea. Once rods and cones convert light into electrical impulses, these signals travel through interconnected nerve cells inside the retina. Eventually they reach the optic nerve, which carries visual information directly to the brain. The optic nerve contains more than 1 million nerve fibers, making it one of the most important communication pathways in the nervous system. Without the optic nerve, even perfectly healthy eyes would be unable to produce vision because the brain would never receive the information collected by the retina. After leaving the eye, the electrical signals travel through several regions of the brain before reaching the visual cortex located in the back of the brain. Here the brain interprets shapes, colors, movement, depth, distance, and patterns, transforming electrical signals into the rich visual world you experience every day. Interestingly, what you actually see is created by your brain rather than your eyes. The eyes simply collect information while the brain processes and interprets it. This is why optical illusions can sometimes fool your vision, because your brain is making assumptions based on previous experiences. The human eye also has several protective mechanisms. Eyelids close automatically to shield the eye from injury. Dust and small particles are removed through blinking. Tears produced by the lacrimal glands keep the surface of the eye moist, wash away debris, and contain natural substances that help prevent infections. Your eyelashes act like tiny filters, preventing dust, insects, and other foreign particles from reaching the eye. Even your eyebrows help by directing sweat and rain away from your eyes. Healthy vision depends on proper nutrition. Vitamin A is essential for maintaining normal retinal function, especially in low-light conditions. Vitamins C and E help protect eye tissues from damage. Omega-3 fatty acids support retinal health, while minerals like zinc contribute to normal vision. Regular eye examinations are equally important. Many eye diseases, including glaucoma, diabetic retinopathy, and macular degeneration, develop slowly without obvious symptoms. Early detection often prevents permanent vision loss, making routine checkups an essential part of maintaining healthy eyesight. Limiting excessive screen time can also help reduce digital eye strain. Following the 20-20-20 rule is a simple habit. Every 20 minutes look at something about 20 feet away for at least 20 seconds. This relaxes the focusing muscles inside your eyes and reduces fatigue. Wearing sunglasses that block harmful ultraviolet rays protects your eyes from long-term damage caused by sunlight. Safety glasses should always be worn during activities that involve flying particles, chemicals, or hazardous equipment. Scientists continue to study the human eye because it remains one of the most complex organs in the body. Advances in ophthalmology, optometry, artificial intelligence, retinal imaging, laser surgery, and gene therapy are helping millions of people preserve or restore their vision every year. New discoveries bring us closer to treating previously incurable eye diseases. The human eye is truly an extraordinary biological system. Every blink, every glance, and every beautiful scene you experience depends on the perfect coordination of the cornea, iris, pupil, lens, retina, optic nerve, and brain. Together they allow you to explore the world, recognize loved ones, appreciate nature, and learn from everything you see. Understanding how your eyes work not only increases your appreciation for the human body but also reminds you how important it is to protect your vision. Healthy eyes are a priceless gift, and caring for them today helps ensure clear sight for many years to come. Thank you for watching, and keep exploring the incredible wonders of the human body.